Hi students, welcome to mathematics class. In the last session, we discussed that math is everywhere. So in this regard, we discussed patterns in mathematics. And while discussing the patterns in mathematics, we have a concept called geometry, which is a branch of mathematics which deals with the shapes. So today, in this session, we are going to discuss in detail about one of that important branch, that is lines and angles. As we discussed, math is everywhere, so the word lines and angles are not new to us. So in our daily routine, either in our classroom also, we can observe these kind of lines and angles around us. So let us see in detail about what is a line, what are the different types of lines, in the same way what is an angle, what are the different types of angles, how to apply these concepts to our daily routine. In this chapter, we will explore some of the most basic ideas of geometry, including points, lines, rays, line segments and angles. These ideas form the building blocks of plain geometry. So whatever concepts here we are going to learn, that is point, line, rays, line segment, these are all fundamental concepts of a branch of mathematics that is called plain geometry. And it will help us to understand more advanced topics in geometry, that is construction and analysis of different shapes. So in the last class, just we have learned what are the different shapes and what are the patterns involved in that shapes. But in this chapter, we are going to learn in detail about how to construct that shapes and what is the logic involved in that construction using the fundamental concepts of plain geometry. So the first and foremost basic concept or the fundamental concept is point. The word point, already we know the general meaning of a point means simply a dot. So with a sharp tip of pencil, if you put a dot or if you observe the needle, a pointed needle, if you observe the tips itself represents a dot. So in mathematical terms, the dot itself is called a point. So mark a dot on the paper with a sharp tip of pencil. So take a pencil, sharpen it and put a dot. A sharp tip of pencil, if you put a dot on a sheet of paper, the dot itself specifies a location. So in mathematical terms, such dots are called points. So a point, the tiny dot will give you an idea of a point. So a point determines a precise location. If I take this screen as a sheet of paper, so here I am placing a dot. So the dot itself specifies a location. So the use of this dot is, the dot is used, generally it is used to specify a location. The best example is Google Maps. So if you observe that Google Maps, to locate a particular location on the map, we will make use of these dots. So that is the use of the point in the daily life. A point determines a precise location, but it has no length, no breadth or no height. It is a zero-dimensional geometric concept. Some models for a point are given below. So here if you observe, here are given some examples of the point where we have a compass which we use in a geometry box. So if you observe the one of the end which is already fixed to that instrument, if you observe that tip, it itself specifies a dot. And if you insert a sharpened pencil, the needle of the pencil itself specifies a location. If you put a dot on a sheet of paper, it also called as a point. Not only this, we can apply the concept to a pointed end of the needle where we can observe the concept called point. So these are the general examples where we will observe the point. So from this, we can conclude that point is a basic geometrical concept which is formed by placing a dot on a sheet of paper. What are the uses of this dot? This dot specifies a location. And what are the properties of a point? A point has no length, no breadth and no height. So these are the characteristics of the first basic fundamental concept of geometry, that is called point. Next, if you mark 3 points on a piece of paper. So let us observe this. So here I marked 3 points. So these 3 points itself specifies a precise location. So you may be required to distinguish these 3 points. You have to name them first. So for this purpose, each of the 3 points may be denoted by a single capital letters. So here I have taken 3 capital letters of English alphabets. One is Z, one is P, one is T. So what is the use of these alphabets? These alphabets, capital letters of English alphabets, are used to denote points. Okay, so these points read as point Z, point P and point T. So this is the way of reading a point. Of course, the dots represent precise locations and must be imagined to be invisibly thin. So here my needle is little bit thin, so you can recognize it. So suppose if I place the dot like this, it is difficult to recognize these points on a plane. For that reason, what we are going to represent these points using capital letters of English alphabets. Line segment. The first one, whatever we discussed, that is the fundamental basic concept, that is point. Okay, now we are moving on to the next concept, that is line segment. So to understand the concept of line segment, let us start with an experiment. Simply, you have to take a piece of paper. So if you have a sheet of paper, please all of you take a sheet of paper. So even I have taken a sheet of paper. So what is the experiment is? Fold a piece of paper. So yes, even I am also folding a piece of paper. In any way, you can fold it horizontally or you can fold vertically. Okay, so here I have taken a sheet of paper and I folded it. Right? And then unfold it. Yes, I unfolded. So if you observe, you can observe a crease where we folded the page. So just this is a reference figure. So if you imagine this rectangle is a sheet of paper where they folded like diagonally. In any way you can fold. And if you unfold it, you will find the crease where we have folded the paper. Right? So do you see a crease? Yes, of course. This gives you the idea of line segment. So from this experiment, we are trying to define a line segment. What is a line segment? Line segment has two endpoints. If you observe the crease, it has two endpoints and there is a crease between those 2 points. So from this experiment, we can conclude that every line segment has two endpoints. Here they labeled it as point A and point B. Mark any 2 points A and B on a sheet of paper and try to connect them by various routes. This is one of the route how I join those 2 points, where we are observing a straight path between those 2 endpoints. And then here if you observe not only a straight path, we can even join them in a curved lines or the crooked lines. So these are the different possible way of joining 2 endpoints. One is a straight path and the other one is a curved path and the other 2 are the crooked paths. Okay. So what is the shortest route from A to B? So many ways are possible. Among all, what is the shortest distance? Obviously, this is the straight path is the shortest distance between A and B, including A and B. So such a shortest path which includes the endpoints is called line segment from A to B. So from this we are trying to define a line segment. The shortest distance between any 2 points including those 2 points is called a line segment. Like after defining the point in the previous case, what we have done, we are trying to denote them. Even here also, we are trying to denote a line segment. So how to denote a line segment? So we will denote this line segment in 2 ways. One is either AB bar or BA bar. Why? Because A and B are the end points of the line segment. Right, and it is a straight path. So to denote that straight path, we will draw a straight line among them. So means I am now going in this direction. It is not only the way, we can even come from B to A also. Right, so in that case, we have to write that line segment as BA bar, including the endpoint. So this is the method of denoting line segments. In any way, you can represent the line segment. So these two representations are same. The points A and B are called the end points of the line segment. Why? Because the path is between those two end points. That's the reason we will call these A and B as the end points of the line segment. The next concept is line. So till now whatever points we covered, one is point and the second one is line segment. Now we are moving to the third fundamental concept of geometry, that is called line. So what is a line? Imagine that the line segment A to B. Already we discussed what is a line segment. What is a line segment? It is a straight path between two endpoints, right, which includes those two endpoints. Now what I am doing is I am trying to extend that line in both the directions, right. So the line segment from A to B is extended beyond A in one direction and beyond B in the other direction without any end. Once observe this figure. Here A to B is a line segment, right? Why? Because it is a straight path between two endpoints. Now what I did, I am extending this line segment towards A, towards B endlessly. So a line segment which extends endlessly in both the direction gives you the idea of line. So do you think you can draw a complete picture of a line? No. Why? Because I used a word called endlessly. Means it don't have any end. So we cannot draw a complete picture of a line on a sheet of paper. Right. So a line through 2 points A and B is written as, already we are familiar with representation of line, right? So this is the representation of line. What it means? It is a straight path between A and B, including the endpoints A and B. Now what I am doing? I am stretching or I am extending it in both the directions. That extendedness is represented by arrows, which means this line segment is endlessly moving towards B as well as endlessly moving towards A. So the representation of a line is AB with a double-sided arrows, which means that that line segment extends endlessly in both the directions. So it extends forever in both directions. So sometimes these lines can be denoted using a small letters of English alphabets. Every time, instead of representing a two-letter representation, in few cases we will even make use of small letters to denote these lines, like line L, line P, line Q, line R. Whereas to denote points we will use capital letters, whereas to denote the lines we use small letters of English alphabet. So in any way we can denote lines, either two-letter representation using capital letters and single letter representation using small letters of English alphabets. Now observe that any 2 points determine a unique line that passes through both of them. So if I observe this particular example where I have taken two endpoints A and B, how many lines can be drawn through this? One and only one line is possible to draw through 2 points. Next concept is ray. The word ray is not new to us. Generally, where we use the word, tell me? Few of the examples where we use the word ray. Yes, the first example, sun rays. Very good. Next, a rays from a light. So in all these cases, we will use the word called ray. From that examples only we can derive or we can understand the definition of a ray. Means it has a source, fixed source. From that fixed source, like if you take sun rays, sun is a fixed source. From sun we are getting the light where it will go through rays. So a ray is a portion of line. A ray is a portion of line that starts at one point, which is called starting point or initial point of the ray. Just now we discussed that is sun rays. Sun is the starting point, right? It will exhibit the light through rays. So sun is the initial point and the rays goes through medium and it will reach the earth and goes endlessly in a direction. And here are some examples of rays. The first one is beam of light from a lighthouse, which we can observe at oceans or sea places. We will observe this light. Okay, so the beam of light from a lighthouse is the best example of the concept of rays. Next, ray of light from a torch. Yes, generally we use even candle. Okay, and also sun rays. Already we discussed it. So in all these cases, that bulb or the sun or the torch bulb, these are all sources of initial points. From there, the rays will go endlessly in all the directions. So that kind of geometrical concept is called ray. Now look at this diagram of a ray. So how we defined a ray? Ray is a part of a line with one initial point and goes endlessly in other direction. So to understand in better, observe this diagram where AP is a line, right? So if I extend here, it will become a line. But what I did, I am fixing it to a point and I am extending it only in one direction towards P. Then such kind of basic geometrical concepts are called rays, where we call A as the initial point. What we call A as initial point. Then how to denote a ray? So generally while denoting a ray, we will start with the initial point. In this example, the ray started from A and it is extending towards P. Then how to draw? Is it okay to represent a ray? No. Why? Because A is the initial point. Yes, but P is not the ending point. So this representation is wrong. Can I write it as like this? No. Why? Because what it means? Double-sided arrows represent. It extends endlessly in both the directions. Is the ray extending endlessly in both the directions? No. Even this representation is also wrong. Then how to write? Yes, you are correct. So just by writing the initial point and you have to write in the direction which it is extending endlessly, and I have to make use of a single-sided arrow, which means that that particular ray is started from A and extending towards P. So till now we discussed three types of representations. One is a line segment representation, which is a bar notation. And the second one is a double-sided arrow, which is a line representation. And the third one is a single-sided arrow, which is the representation of ray. Don't get confused. If the end points includes, it is a line segment. If the line segment extends endlessly, then it is called line. If I take a part of a line with one end point and extends endlessly in other direction, that is called ray. So these are the three fundamental concepts of plane geometry. One is line segment, one is line, and the third one is a ray.